Welcome to Arize Observe. I'm Jason Lopatecki, co-founder here at Arize. Excited to have you here today. Most of the world's data is unstructured. Almost, a large portion of the world's data is unstructured. And the most complicated models in the world, deep learning models, work on unstructured data. So we're here to tell you about both product launch as well as new features that we've built out to support unstructured data and deep learning models. We did a survey of our teams, and 80% of the data out there that teams deal with in a production setting is unstructured data. And then, add on to that, 0.1% of that data is labeled. You cannot tell what this, it's very hard for a model to understand if what it's doing and how it's acting on this data is correct. Very tough to work with. And what this the challenges this adds to is that this data can change underneath teams and you can be completely unaware of it. It's hard to know when unstructured data is different than when you built it. It's also doubly hard to know if the decisions your models are making on unstructured data are correct in production. It's not labeled. Very, very hard environment to work in. And it's very different than the environment the model was built in, which typically is great. It's got English words, well-formed, very, very clean data, which is what the model's built on to act on. When you put the model in production, the data can look very different. It can be Spanish versus English words. The data could, data can be drastically different than what you saw in your production. In production versus your training environments. And what this means to teams is performance might drop. The data it's acting on is very different than what it was built on, and it's not doing what you want it to do. This gets even harder for large, complex, deep learning models, which is where embeddings come in, and Aparna is going to tell you a bit about that.
Awesome. Thanks, Jason. Embeddings are everywhere. If you take anything away from this talk that Jason and I are part of, I hope it's that embeddings are everywhere. They're in GPT-3, they're behind DALL-E 2, released by OpenAI, and they're really the backbone behind a lot of the deep learning models and complex models deployed out there. And because they're everywhere, they're really the perfect interface to use to troubleshoot these types of models. Whether it's a computer vision model looking at, is this a cancerous cell or not? Or it's an NLP model doing speech recognition. Embeddings are the internal representation of what the models learn, and it's passed to Arize for observability. And we'll explain a little bit today about our new product launch that we've just recently released to the public that supports unstructured data and embeddings. So first off, what are embeddings? Well, embeddings, you can think about it really as this mathematical, vector representation of the data that captures some of the semantic meaning. This data could be words, like in this example here. In this case, we'd call it a word embedding, but embeddings can also represent images, audio signals, large chunks of unstructured data. And what it does is it compresses the data and it preserves the relationships within your data. So words that are similar to each other will show up. We'll have a vector that's closer together in distance. Words that are further apart from each other will be further apart. And so you can think about it as really output of these deep learning layers that contain the structure of what the models learned and can be used to troubleshoot unstructured models. And it's really the best way to get at the why behind AI. And you might be wondering, well, hey, Aparna, isn't that what explainability is for? Isn't explainability supposed to give me my why? Well, explainability actually might not always be the best thing to help you troubleshoot this type of data. And I'll give you an example. This is an image, classification use case, trying to predict, is this a panda or not? And if you use something like an integrated gradients, what it would actually show you is which pixels in these images were most relevant to the prediction, whereas most relevant to the classification of, is this a panda or not? But just knowing as a data scientist or an ML engineer, knowing what pixels may not always be the most helpful to help you troubleshoot, well, why did the model make that decision? Versus an embedding, you can think about the embedding as really this internal slice of what the model's learned, compressed into a single vector. And that embedding can contain information like, well, does this image have of a panda have similar features to a bear? Does it have, what color fur does it have? What color is this panda's face? And so you can actually learn some of the structure of what the models learn, and it can be much more useful in troubleshooting these types of unstructured data than explainability even can be. And so what we launched really is leveraging embeddings to be able to do observability for unstructured data. What we've launched monitors every single embedding, identifies patterns of change across these embeddings, and then provides tools to be able to export problematic samples to use for either better labeling or better data quality measures if the data itself needs to be fixed. And let me tell you a little bit of how this works. So what we do is collect, monitor, and index every single embedding. So this is every production inference that your model is making. We monitor the embedding, and we bubble up when there's problematic segments. So in the example that Jason was sharing, where there is Spanish words now being tossed into the data, it would actually identify those problematic segments and then also find similar examples to those problematic segments. So because we're collecting all of the production data, we can actually bubble up where the problems are, where the model is not doing so well, what are outliers when there's changes, and then go back through all of the production inferences to find similar data points that can then be exported to either a labeling provider or sent back to your data team to figure out what changed and how it's impacting your model. And let me go a little bit into the technical details of how we do this. So we actually measure a concept called embedding drift. What we're doing is actually collecting all these embedding vectors and then looking at the distance between a baseline group of vectors and then what the model's actually seeing in production. And the distance itself, you can think about it as either Euclidean distance or cosine distance, but we're looking at basically a baseline group of vectors, and then that distance is taken in the high dimensional space. And so it's looking at the distance between maybe your training data set, which could be your baseline, versus what actually the model's seeing in production. And then there's workflows when drift has been detected to actually drill down into interactive visualizations to identify what are those problematic segments or groups that are causing that drift. And so in this example here, you might see a pocket of data here, which is kind of the Spanish data, the Spanish data points. And you can actually see that there's an outlier group that's showing up just in production, wasn't there in training. Really quickly, ML engineer, data scientist can grab this and say, well, looks like we need to label more data from a different language that the model is now seeing in production. And what this is really creating is a workflow to be able to export problematic samples to fix underlying data quality or data issues, really empowering this data-centric AI workflow to collect issues, collect data from production, understand when that data has actually changed, troubleshoot it, and then use that same data to go back and fix your data to improve the models. And I'll show you how all this works with a quick demo of the product itself. And so what I'm showing you here is actually the Arize product itself. What you can see in the Arize product is not only, so this is an example, same example we've been going through, which is kind of a model which is collecting reviews. These reviews can be, every e-commerce company probably has an ML model that's looking at the reviews that customers are providing underneath products. And what we're looking at here is the model schema not only has structured data, but also has unstructured data, which now users can provide through embeddings. These embeddings can then be collected. In this case, it's a text vector. And these embeddings can then be monitored for drift. And in this example here, what I'm going to show you is at some time period, looks like in May and June, the text vector wasn't experiencing any drift. I can actually go and take a look at that data itself right now. And it looks like there's kind of two big pockets of data, group of data points where the reviews are positive, group of data points where the reviews are negative. So looks like there's kind of a, two broad segments of reviews, but at some point kind of mid-June, it looks like there's actually some spike in this text vector. Means the data has actually changed. Need to understand what's changed in the underlying data. And this is extremely complicated to troubleshoot. I can't tell you, you think troubleshooting regular ML is hard. Troubleshooting unstructured data, there's really no tools to be able to do this out there at production, at scale. And so what you can see here is I can zoom in and look at kind of again, a 3D visualization using UMAP of that time window when there was actually drift in this vector. And it's very clear there's a group of data points here that's actually distinctly different than what I'm used to seeing when there wasn't any drift. I can actually zoom in, go look at how the structure of the data has actually changed. I can go click on individual data points, and it's really clear once I go look at the raw data, these are my Spanish data points that are showing up in production, wasn't there in training, vastly different. Model doesn't really know what to do with these data points. It's not doing so well on these data points. And product was able to figure out that there was drift in this type of complex vectors and data in the product. Hopefully that gives you a little teaser of what we've released and what we've launched. Definitely check out Amber's workshop later today so that you can try it out on your own. And really encourage all teams that have unstructured data to give it a shot, give it a try. Future of ML is going to involve unstructured data, and we're going to need better tools to be able to troubleshoot this type of data. Thanks, everyone.